Hello and welcome. My name is Sajawal Zahid. So today we are going to do the quadratics topic from CAIE Cambridge as well as Edexcel paper 1. So the first topic is basically we will learn how to convert a quadratic equation into a completed square form. So quadratic equation, general equation form is ax squared plus bx plus c, as you know. So this we need to convert into the form of a bracket x minus h whole square plus k. This minus can be plus also. So the advantage of this complete square form is that it will be very useful to make the sketch of the quadratic equation. You can directly find the minimum or maximum point and the y-intercept. So it's useful to sketch the quadratic equation, locate the vertex means turning point, which can be maximum as well as minimum, and also later in the next chapter it will help us to find the range of the quadratic functions. So let's see an example. Let's express 2x squared plus 12x plus 11 into the completed square form. So first step is always to make the coefficient of x squared 1. So we will take 2 common from the first two terms, x squared plus 2x. We don't need to touch the last number 11. We'll keep it the same. The next step is to divide the coefficient of x by 2. Half of 6 is 3. Add its square, subtract its square. So you will always divide the coefficient of x into half, and then you will add the square of that number and also subtract the square of that number. Okay. Then the first three terms will become the complete square. If you have x squared plus 6x, it will become x plus 3 whole square. If you have x squared minus 6x, it will become x minus 3 whole square. Second last step, you will attach the 2 with the bracket, and then you will multiply 2 with minus 9, that will become minus 18. And minus 18 plus 9 becomes minus 7. So this is the complete square form in the form of a into x plus minus h whole square plus k. So now the y value of the turning point, in this case minimum point, is directly the last number minus 7, whereas the x coordinate is the opposite of 3, which is minus 3. You will always take the opposite sign in the bracket. The number which will be there, you need to take the opposite sign. The reason it's a minimum curve, because the coefficient of x square is positive. If you have the coefficient of x square negative in the original form or the last one, it will have a maximum curve. Next topic in this chapter is how we can use the discriminant of the quadratic equation to determine the nature of the roots. So roots or the x-intercepts, we can have a quadratic equation can cross the x-axis 2 times. So 2 real roots. It can be tangent, 1 root, repeated root, and it may not cross the x-axis, no root. So basically it's the term under the square root b square minus 4ac. You must have seen this formula when you use quadratic formula to solve quadratic equation. So b square minus 4ac basically determines the number of roots. If it's greater than 0, 2 roots, distinct roots, equal to 0, 1 root, less than 0, no root. Actually there is an issue with this slide. B square minus 4ac less than 0, that should be the right one. B square minus 4ac equal to 0, that should be the middle one. So let's see an example. We are going to first find the discriminant of this equation. So a is equal to 3, b is equal to 4, and c is equal to 1. So b square minus 4ac, 4 square minus 4 into 3 into 1, that's a positive number. So whenever you have a positive number, you will have 2 different roots. So as you can see in the actual graph also, the curve is crossing the x-axis at 2 points. And then we can extend this concept to find the intersection points between line and a quadratic equation also. First you need to equate the quadratic equation to the line, and then you need to simplify the equation, make it one quadratic equation. So this is a general form, mx plus c is equal to ax squared plus bx plus c. Once you simplify that, again you can use the discriminant to find the number of intersection points. So as you can see in this diagram, when the discriminant is greater than 0, 2 intersection points, discriminant equal to 0, 1 intersection point, it's a tangent, the line is tangent to the curve, and when the discriminant is less than 0, there will be no intersection point. So let's see an example. So here we have a quadratic equation as well as a line equation given, and it's given that the line and curve are tangent. So that means when we will equate the curve and equation, we will simplify it to a quadratic equation. When we will find the discriminant, we will make it equal to 0 because the line is tangent to the curve. That will help us find the value of k. So here we have done the process. First we will equate the quadratic equation to line, move the terms to the left side, combine the coefficient of x, we took x common from kx and minus 2x, so that we have the ABC terms from the quadratic equation. So here you can see a is 2, b is k minus 2, and c is k minus 4. So from here you need to find the discriminant, b square minus 4ac. This turns out to be a quadratic equation in terms of k. So this quadratic equation now we will equate equal to 0 because the curve is tangent to the line. So that means we have to solve for k, and it turns out there is just one value of k for which the discriminant will be equal to 0. Alright, so that will be all, and we will continue in the next video.